Welcome back to this channel. Under this tutorial, we are looking at the inverse of a square matrix. So the inverse of a matrix A is written as A inverse, such that when you multiply the matrix by its inverse, you are going to get an identity matrix. And what is an identity matrix? An identity matrix is of the form, suppose this A is a 3 by 3 matrix, then the identity elements or the identity matrix for multiplying the matrix A by its inverse is going to be 1 0 0 0 1 0 0 0 1. So this is also a diagonal matrix. Great. So as I said earlier on, the inverse of a square matrix is written as this. And when you multiply a matrix by its inverse, you are going to get the identity matrix, which is of this form. That is great. Now, an inverse, then the question is, how do we find the inverse of a square matrix? Now, the inverse of a square matrix is found by inverse. First of all, you need to find the identity of the matrix. Sorry, you need to find the determinant of the matrix, which is of this form. So it will be 1 out of the determinants. Then the matrix given to you, what you do is that you swap the elements. So let's say you were given Z, sorry, let's say you are given A to be W, and here is Z, and let's say here is X and here is Y. So what you do is that you swap the elements in the diagonal matrix. So you are going to have, you change their position. So here we are going to have Z and W. Then the next one too, you maintain them, but you negate. So you negate X and then you negate Y. So that is what we have here. So the identity matrix, sorry, the inverse of a square matrix is found by, first of all, finding the determinants of them of that particular matrix. Then you first, after that, you find 1 out of the determinants. Then you swap the elements of the diagonal matrix here, and then you maintain the second diagonal entries, and then you negate them. Great. So let's say you have a matrix of this form, a matrix A equal to, let's say X, let me use W. So W, X, Y, Z. So the determinant of A is equal to, multiply this by this, minus Y times X. So we're going to have XY. So that is the determinant for this. Then the next one is to, after finding the determinants, we need to swap the elements in the diagonal entry. So here we are going to have Z, W. Then we negate the entries in the second diagonal. So here too, we negate them, but we maintain. That is what we have here. So we are going to have 1 over the determinant, which is this side, WZ minus XY times this. So we are going to have Z negative X negative Y W. So that is how we find the inverse of a determinant, sorry, the inverse of a square matrix. Now let's look at this question. In this particular question, we are using the inverse to solve matrix equation. So we are given a simultaneous equation, 2x plus 3y equals to 4, x minus 2y equals to 5. Now, this equation can be written in matrix form as A, which is 2, 3, 1, negative 2. Great. So how we find how to solve this particular equation is ax is equal to b, where x represents the variables over here. So let's represent this one as x1, x2, which is equal to the results, which is 4, 5. So here b represents this, x represents that, and a represents this. So this has been written in this form, where the matrix here a represents this one, and then x represents the values of the variables, and then 4 and 5 represent b. So as usual, a inverse is written as this. So if you want to find the value of x, then x is equal to a inverse of b, and that is what you have here. Now let's find the inverse. So for a inverse, we consider finding the determinants. So of course we add the matrix to be 2, 3, 1, negative 2. So the determinant is 2, we have 2, 3, 1, negative 2. And this is equal to 2 times negative 2 minus into brackets 3 times 1. So 2 times negative 2 is negative 4. Negative 3 times 1 is 3. And that gives us negative 7. And that is what we have here. 2 times negative 2 minus 3 times 1. Okay, so now let's take the inverse of the determinant a. So we are going to have 1 on the determinant times, as I said earlier on, we swap the values, we swap the entries in the diagonal matrix here. So here we are going to have negative 2, 2, and that is what we have here. So we've swapped the elements, we have changed their position. Then the second one, too, we maintain them, but we negate both of them, and that's why you have this one here. Okay, great. So the next thing is to multiply through each entry by this value. So don't forget that we had the determinant to be negative 7. That's why we have 1 on negative 7 here. So when we multiply negative 1 on 7 by negative 2, we are going to have 2. We are going to have negative 1 on 7 times negative 2. And that gives us 2 on 7. The negative 1 on 7 times negative 3. We are going to have 3 on 7. And that's what you have here. The negative 1 on 7 times negative 1 is negative 1 times negative 1 on 7, and that gives us 1 on 7. And the negative 1 on 7 times 2 gives us negative 1 on 7 times 2, which gives us negative 2 on 7. And that's what we have here. Okay, so now let's multiply 4, 5, which is this course, of course, this one by the results here. So that's why we have this one over here. So when we take this, we are multiplying this one by this. So we have 2, 7 times 4 plus 3 on 7 times 5. And then we take this one to 1 on 7 times 4 plus negative 2 on 7 times 5. So in this case, we are going to have 4 times 2 is 8 on 7 plus 3 times 15. 3 times 5 is 15 on 7. And this one, you are going to have 4 on 7. These are all in brackets. 4 on 7 minus 2 on 2 times 5, which is 10. Which is 10.